right. I've had this kind of thing I've been thinking about in the last year or so. Um, the not just the history of Kafka, but the way Kafka penetrates organizations, the way people start using it, and then what it ends up doing to them. And I think I've seen a parallel between those two things, between the way Kafka has developed as a platform and the way, even if you start today, like if you weren't using Kafka 8 years ago, like some crazy early adopter, you just start today, you kind of like relive that same process. And I've been thinking of this idea of development. And I don't mean software development, I don't mean real estate development. Um, I mean like developmental processes that people go through, that living things go through, that teams go through. And I think that's kind of the way what I want to talk about tonight is these developmental stages that Kafka has gone through, and the developmental stages that teams and organizations go through in adopting Kafka. And it's nice to look at that because we can kind of see where we are along that process. And where we are is important and it's good. And we have some idea of where we're going to get by watching other things having developed. Part of this is probably influenced by the fact also that I just became a grandpa in July. That's me with Alexander Flynn. And, at this stage of development that all of us who are listening were at this stage at one point, like you don't do much, you sleep and you eat, you cry a little bit. And, what do you do with a person like that? Well, you hold them, make you feed them, you keep them clean, give them a warm place to sleep. That's really all there is. There's not like a whole lot of interaction. But hey, babies are great. And we go from there through other stages. He's just 4 months old now. This was July, so he's still pretty small. But he'll smile at you now, and he kind of, he'll laugh at things a little bit. He's developing. He's going through stages. Companies do this. I see companies do this. So I've worked for a few startups, and I think that there are some kind of main phases of startup life. I think kind of from founding to about 75 people. Once you get past around 75, then it feels like the really early on people have a shared identity. Like, here we were the early folks, and now all these new people are here. And it's not like it was at the beginning. You start to have that sense around 75. Then around 250 people, there's this other phase you go through where things really start to feel formal, and there's executives who are leading functions, and it's like, kind of a real company. It's still pretty small. It's not 5,000 like 5,000 developers like Wix. And then I think around 800 people, you really get to the point where leadership is focused on process and scale and things like that. And it feels like a totally different thing. So companies go through these phases. People do, companies do, software does. And in America, this is a very recognizable kind of macaroni and cheese. You could tell by the color that it's Kraft macaroni and cheese, because actual cheese is not that color, but the powder that this stuff comes with is that color. And this is like a very stereotypical little kid food in the United States. So you could be 3 years old and just want to eat this 3 times a day and think this is a fulfilling life, and I can't believe I get to eat this wonderful food. And then you as an adult might come back and try to eat it and think, well, I have fond memories of making this when I was 10, but this isn't good food. So it's important to realize that that little kid who loves Kraft macaroni and cheese isn't stupid or isn't bad. It's just at an earlier stage of development. And then you, at a later stage, you have different requirements. There's other things you want to be eating. Kafka works that same way. And I think the organizations that adopt Kafka work that same way. We go through these same kind of phases. And it's important to not to look down on the macaroni and cheese phase, but also to want to grow past it, because it's not good to stay there. So let's look at where we start. A lot of companies start. Now, you just heard Nitin give, frankly, a very sophisticated account of a company that has made deep Kafka adoption and done, I don't want to overly flatter him, but honestly, some industry leading thinking on how to do this right. A lot of companies aren't there, and a lot of companies start with something very simple, which is just integration between two things, right? There's something happening in one application, and I need that to happen. I need that to get to the other application. So this is the very, very simplest thing you can do with Kafka. And it's almost like what you can do with messaging systems, right? Sometimes this is where Kafka kind of competes with messaging systems. Kafka's not a messaging system. It's not a direct competitor for ActiveMQ or RabbitMQ or any of those. It's a different kind of thing, but this early use kind of feels the same way. And it's interesting to look at what had to be present. If you think about little kids, and remember, I'm trying to make this human development analogy here. When you think about little kids, like a 3-year-old is not good at very much. One of my daughters, who's herself, she's all grown up, she worked for a few years coaching toddler gymnastics. And she always said that the mission is not for these kids to learn gymnastics. It's for them to learn to obey somebody who's not their mom and to not hit their head on things as much. So she loves kids, but she realizes they're just not good at much. But even so, people who are 3 years old are capable of some really sophisticated behavior of like object recognition and natural language. And fine, they're not that good at talking, but they're better than Alexa a lot of the time. So, there's a lot of capability that had to be present in Kafka for this to work. We had to have topics, right? Topics are kind of the fundamental thing, the fundamental piece of Kafka. There is no Kafka without this. And the very first, right out of the gate, Kafka had this commitment to topics being logs, to being persistent storage. Natan talked about that, how it's possible to use topics to store things, and so they are. And Kafka figured out had a way right away from the beginning of partitioning topics. You could split one up into multiple pieces and put those pieces onto different machines, run them on different machines, which got us, it brought up the question of how to assign messages to topics. And Kafka came up with this way of by default, using the key. Each message is a key value pair, and it would hash the key before assigning it to a partition. And based on the hash of the partition, it would write it into the same partition. The same key always goes to the same partition. This is just Kafka right out of the gate. So producers, there was a producer library, and there still is a producer library baked into Kafka. This handles all the network plumbing and retries and, well, all that hashing stuff I just talked about. That's what producers do. And consumers, Kafka had a way of consuming from partitions right out of the gate. So toddler Kafka, you had this ability to have multiple consumers on a topic, which was super interesting relative to the messaging systems that had come before, right? Just because one consumer is reading from a partition doesn't mean another one can't. And you had this way of horizontally scaling consumers by adding an additional instance. The consumer group and the cluster would cooperate to reassign partitions fairly between the topic and the consumer group. This is all, and that, if you think about it, you could kind of get a horizontally scalable, elastically horizontally scalable application without doing anything. Now, if you've done this before, that's kind of a big kind of. There are things that are missing here. But again, it's like a little kid. Lots of speech, lots of image recognition, lots of relationship capability. There's all kinds of things, even though they're not good at much, that they still do. And so consumers worked that way. Now from there, people start to, again, the initial use might be just to ship events from one place to another. There's a bunch of functionality that has to be present in Kafka for that to work, but things start happening. So let's suppose that shipping events from one place to another is this real common use case called mainframe offload. Now, if you don't have any mainframes in your life, this is not obvious. If you do have mainframes in your life, it is obvious, but I'll explain it real quick. The idea is that you get charged for computation, for the time a program spends running on a particular CPU. You get charged for I/O. So it's this very by the drink sort of billing model in the mainframe. I don't know, it's kind of like the cloud. We pay per unit of computation and per unit of IO in the cloud. Mainframes were doing that 2 generations ago. But if you're spinning up some new application, it could be expensive to do lots of queries against the mainframe. So what people will do is they'll offload that data into a Kafka topic. They'll get it out of the mainframe database and put it into a topic, and then maybe consume it in that consuming application and populate a temporary database, a materialized view of that data in a database local to that service or to that application. That's just the basic shape of mainframe offload. Now, once that data is in that topic, it's basically free to access. You're not paying per query anymore. So what happens is other things grow up. There's other applications that want to read from it. Maybe you want to store it somewhere for the data science team to get to it. You want it to be searchable. Maybe there are other legacy applications that you want to offload into Kafka because you realize that having data in topics is actually kind of valuable. Once you start to use it, you want more data to be in topics. So it goes from this point to point to this many point to many point interconnected thing, something like a central nervous system. And before you're thinking about Kafka is very sophisticated, because saying it's a central nervous system implies that you've got some like big strategy and unified application architecture. Before you even get there, you still have this web of data, and then you tend to evolve very naturally, develop very naturally from that single point to point thing to this general integration platform. But there's a problem here, and that's those arrows. All those arrows, once people started doing this, they realized they had to write the code for those arrows over and over again, which is not particularly rewarding because it's exactly the same thing for you to dump data into Elastic as for your competitor to dump data into Elastic, or to read from a mainframe or read from a relational database. And so Kafka Connect entered the scene. This became, in 2005, a capability that Kafka had as a platform. The platform developed to keep pace with the things it was trying to do. And again, if you have kids, if you think of the way their development proceeds, suddenly they're able to do some new thing. And so they do a lot of it. And that might cause them to develop some other skill, like they're able to speak now. And now suddenly they have to develop social skills and learn, well, you don't say that kind of thing to strangers. If you have young children, then you know that's painfully true. Well, Kafka had to grow Connect. And Connect is this general purpose data integration framework that's a part of Kafka that now has a pluggable system for doing things like writing into Elastic, writing into S3, reading from a relational database. Confluent keeps a hub of these things, hub.confluent.io. There are connectors, converters, single message transforms, all the modular pieces of Kafka Connect that are all available for download here. And of course, you can find this stuff on GitHub. I mean, it's everywhere, but Confluent gives a somewhat curated collection of those things. All right, so a new capability and kind of a new way that Kafka tends to develop and things that start to happen is something happens to ETL. Once we've got data in topics, things happen. So remember how ETL used to work? You had I'm showing it as one big giant mainframe, obviously over on the left there. That's 200 databases. It's all kinds of crazy things. And we have some nightly batch process that reads from those, does a bunch of cleaning and aggregating and pre-computing, and dumps the process data into a specialized database. So this whole really tradition grew up around the idea that we needed to run reports. And the best we could do was to do that nightly because it was computationally expensive at the time. 30 years ago when people started doing this, it was difficult. And it was this nightly batch thing. So if you wanted to understand what happened in the business yesterday, that was cool. Well, think about what happens here, though. I'm already doing this offload. I'm already tending to want my data to live in topics. And if my data lives in topics, I can still write a batch process at night if I want. But the way people use analytics is honestly changing. It's not so much that a report gets prepared, it gets handed to some important person in an oak paneled room in the morning describing what happened yesterday or last week or something like that. But increasingly, analytics is used to drive real-time decisions that even people fairly low down in an org chart, individual contributors, kind of need to know what's going on in some ways. That's a change in business that kind of coincides with this change in the way we can do things. So we've got this new developmental capability. We've got data in topics. Well, now I can just write a stream processor that consumes from that topic, does the aggregation in real time, and emits results to some new topic, which of course is now accessible to other applications, to storage, to search, to whatever we want to do with it. And I've already got the ability to do this, all right? If I've got connect, that's nice. Connect keeps me from rewriting too many of those arrows. And I've got the ability to consume and the ability to produce, and I can write a program myself. I can do this, but this started to show that there was something new that needed to happen, right? Once you're writing all those stream processors, you're doing the same thing over and over again. You're going to be doing grouping, windowing, aggregating, joining, enriching, all this kind of stuff that just happens in real-time ETL. We don't want to do that over and over and over again. So Kafka Streams emerged. That's this Java API that kind of borrows from functional concepts that rather than just saying, your abstraction is a topic and a message, now it gives it these higher level of abstractions called streams and tables. These are objects in the API that correspond to topics. They're like layers on top of topics, but we get to program them like we're programmers and do things like if you have a stream and you want to group by some field, well, you can turn that into a grouped stream by identifying that field. If you want to run an aggregate, a reducing function over that group, you can provide that function and it gets run for you. So this much higher level of programming than we're used to with just consuming. Also, consumers were scalable, but they really didn't do anything with state. And this is really another great example of this developmental mindset. Yeah, you could scale out, but if you're doing anything stateful, you kind of had to, really restart the consumer group or just spin up a new one and turn off the old one. That process was difficult. There was no way to do that dynamically. Well, now Kafka with Kafka Streams has grown this new capability, this kind of maturing capability of doing that better. And, you don't have to write boilerplate for doing all the stream processing and real-time ETL kinds of stuff that people had to do, computing aggregations and joining and all that kind of stuff, because you don't want to build that framework code. Just like you don't want to build Kafka Connect over and over again, you don't want to build this kind of framework code because it's really hard to do. And if you don't know Kafka, I think many of you in the room know Kafka Streams. If you don't know it, its main interesting opinion is that it runs as a library. So it's a part of your consuming application. It's not a separate stream processing cluster that you spin up. It's just functionality that you depend on as a Java application. And you code against this API and now you're a Streams app. Streams code looks kind of like this. This is, I don't intend for you to actually study this. The Confluent DevRel team has a GitHub repo called Demo Scene. That's Confluent Inc/demo-scene. And this is the movie rating demo that's in there somewhere. So it's fairly readable. I mean, this is scrolling too fast. We're not really looking at it, but it takes a bit of code to get things done, which gets us to our last really, feature in the platform, and that's ksqldb. So this is like Kafka Streams, but in SQL is kind of what it is. The same stream and table abstractions, the same filter, join, aggregate things. It's extendable in JVM languages. You can write, it's a really, really simple API, just like a couple of annotations, and you can write a custom user-defined function or user-defined aggregator and deploy those as a part of your ksqldb app. It doesn't run as a library with your Java program, obviously, because it's parsing and executing SQL. So there is its own, there you have your own ksqldb cluster that you throw queries at and it executes them. Architecturally, it looks like this. You've got some source of events, they go into a topic, ksqldb query consumes from that topic. There may be many topics that a single query is consuming from, but at least one, and it does, the computation runs over the cluster, and then it emits its results to a new topic. And that code looks something like this. This is a little bit of a cheat, but this is basically the same computation that Kafka Streams code was doing. Now, to be really, really the same, I'd have to show you some DDL. There'd be a create stream and a create table. and might have to monkey around with one of the streams to get the key right. So to say all of that Kafka streams shrinks down to this case SQL is a little bit not true, but the basic heart of the computation is expressed here. And it is, of course, being SQL, more expressive than Java code. That is, for each, for each unit of code in SQL, we're talking about more work being done than in the equivalent Java API. That's definitely true. So where does this get us, though? So we have this now kind of completed platform and this new set of capabilities. But let's talk about what this ought to do now to application architecture. This is like, all of a sudden discovering you're an adult and you can engage in adult relationships and talk to people and eat adult food and drink adult drinks and think adult thoughts. Now, what's your life going to be like compared to when you were 12 and you didn't have those capabilities? Well, let me tell you that story from an application architecture perspective. And this, I think, builds a little bit on some of the things Natan was talking about. He was giving us a really big overview of just the way Wix uses Kafka and the capabilities that Greyhound has. And he talked a little bit about how their services interact. So this, and we could talk later about how Wixy this is, but this is a good vision for what Kafka ought to do to application architectures. Let's start with doing this with RPC, or synchronously integrated microservices. I'm going to be doing an e-commerce system, and very, very minimal e-commerce system, such as might fit on a slide. But right now we've got a service that takes orders and a service that lets me manage user accounts. That sounds like a good start, right? So we can take orders, we can manage accounts. Let's see what else we have to do. If an order comes in, the order service has to call synchronously the payment service because we need something to get paid, right? Well, that's going to call some payment gateway and a response will come back. And maybe then we'll have the payment service call the shipping service. We could also have the order service call the shipping service, but hey, this works better for now. So the shipping service is ready to go, ready to ship this thing, but unfortunately it has a user ID and not a name, address, and phone number. It needs a name, address, and phone number because our shipping service, our shipper doesn't know anything about our user IDs. So now it has to call synchronously the user service, which will look up that user and return the name, address, and phone number to the shipping service. So it can now enrich the order object with that data, send it off to the warehouse. Warehouse says, okay, we got it. And that is complete. Now, that's all synchronous. That works. It's in a sense, it's okay, but of course, there are problems with all that synchronous integration. So let's refactor that to events. This vision that I'm about to propose here is really what I think Kafka does, and what adult Kafka does to application architecture. So that first synchronous call between orders and payments, we're going to replace with a topic. So now all orders does, when it's done validating the order, is produces a message, and that's it. It doesn't wait around to make sure the order got shipped. It doesn't know whether the order got shipped. That's somebody else's responsibility. It just puts a validated order in that topic and expects somebody else to pick it up. And of course, payments is that service. Payments can now consume from that topic, do the payment gateway thing, which, by the way, is still going to be synchronous. I mean, there may be no getting around that. Maybe that's just what our payment gateway API is. When that response comes back, though, it will be able to pass it on to shipping, which it does asynchronously. You do that by producing a message to a topic, and the shipping service consumes that message. Does payments know that shipping is consuming that topic? No, it doesn't. It's not up to payments to know what happens next. It's up to payments to do its work and produce the result. Now, this is important because with this sort of toy system here that, again, it's like pedagogically useful. It's simple enough that everybody can just kind of understand it at a glance, and we can focus on other concepts. Now, if you're really building an e-commerce site, it's not 4 services. It's a lot more than this. But with just this simplified thing in view here, something cool has already happened. Now, as I said, orders, we produce the message. We don't care whether it gets paid or whether anything happens with it. Payments picks the order up, does the payment, produces the result with the order object enriched with a payment reference ID or whatever. Doesn't care if it gets shipped. It has to trust the other services to be adults. Now, we know it goes order, pay, ship, because we can look at this, but the services don't know. The other thing that we don't know at this point is what else might happen with that data. Because RPC calls are ephemeral, right? The call happens and the result comes back and it evaporates. Now, something's getting logged there, right? There's some way of observing the system, but that's logging for the sake of observability, not for the sake of being a system of record. Here, the system of record, the interaction of the components of the business are now logged. And if I want to stand up some other service that maybe detects fraud, and maybe I need both of those topics, and like I need to join them somehow to be able to do fraud detection and some other data sources. I have that. What if I want to spin up a service to reward frequent customers? Well, I could consume that order service data and I could build that service. Like, you have people in your company who can discover the data and build valuable things without you knowing. All you're doing is producing your result, but the data now is there, and you can have this kind of ecosystem effect of functionality emerging in the organization when other people in other parts of the business discover it. That's cool on its own. There's another cool thing here. Data gets in the way when it comes to microservices, right? It's usually easy to functionally decompose our system. Like here, we have this shipping service and the user service, that's easy enough. But shipping needs that data, that user data. And we're trying to avoid synchronous interfaces. So what do? Well, it's straightforward to create a change log of what happens to the user data. This can be done in Kafka Streams. This can be done manually. This can be done with Kafka Connect. But every message in that new topic is, we produce a message there when we create or update or delete a user. And with that change log now, and again, with Kafka Streams, KSQLDB, this becomes pretty trivial. I can materialize that as a local read-only view. I now have in-memory key lookup access to users' data, so that when I need to enrich paid orders with user data, I could do that in a performant way inside the shipping service, and I don't have to have any kind of direct access to the actual database of users. The user service is mediating that data to me by way of this change log, this log of immutable change events. So a bunch of cool things happen when we've got this fully grown platform in place. And we started by thinking about the idea of development and developmental phases and this picture of macaroni and cheese. I hope it's not like super unappetizing to you. I mean, you've probably eaten by now, but again, a lot of little kids just consider this to be gold in America, and I've never understood it. My kids did. I still don't know why, but they grow out of it. And this is an important phase for people to be in, just like adulthood is. So if you look at how the platform developed, the phases it went through. Early Kafka, what did it have? It had topics. It didn't even have replication at first. That wasn't until 0.8, I think in like 2012, that Kafka had replication. It had a standardized data integration framework, Kafka Connect, 2015. Schema management, the CONFLUENT schema registry, we didn't even talk about that. That was a thing that came along. Kafka Streams in 2017. Suddenly, this is looking like a serious framework. There's this way to do advanced computation, data integration, logging, it's kind of all there. A SQL has to happen, and so Confluent created KSQLDB, and Confluent made a cloud offering, and this stuff has to happen in the cloud. There are lots of different places to run in the cloud. My employer is one of them, and with that in place, it feels like, okay, this thing's fully grown. Now, we always kind of sit where we are and see ourselves as grown and mature, and I'm doing that with Kafka right now. I'm thinking the pieces are here. Man, there's still stuff that needs to grow, like schema management for the enterprise needs to get all this cool stuff. Like, yeah, okay, that's all there, but boy, we're fully grown adults. Just like when you're 12, you think that, and I don't know how much growing we still have to do, but it really feels like this is pretty good where we are. And it mirrors the stages organizations go through. You might start by trying to ship events from one place to another. And maybe that's offloading a mainframe, maybe it's some other legacy application. Pretty soon you've got lots of things wanting to talk to each other. You're wanting to use Kafka Connect and do data integration. And sometimes real-time ETL is what motivates people to start with Kafka. Sometimes people just jump right into this stage. But once you've got data and topics, you're going to want to do computation on it. That's just how it works. And then finally, we see that vision of microservices that I presented, which I think is an evolvable and scalable software architecture. I think that's something advocates of microservices have been saying for almost a decade now, but hasn't really been true. It's starting to be true. It's like, as fully grown Kafka, we can kind of do that now. Anyway, think about where you are in this process. Maybe you're at the very beginning. You came here because you're interested in learning something. Maybe you're using Kafka like a message queue at your company. Maybe you should be sending a talk to Kafka Summit London. The CFP is open right now. You should Google that and put a talk in if you'd like about what you're doing. Like the stuff Natan is doing. You should be talking at Summit. There are probably other people in the room where your usage of Kafka is adult enough and sophisticated enough. Darn it, people need to learn what you're doing. So wherever you are, it's a good place, and it's good to see how this process works and how you're likely to continue along this spectrum if you keep it up. Hey, if you want to know more, especially if you're getting started, check out Confluent Developer. It's a website we made a while ago, and we just put a bunch of new content on it this summer. It's there for you, so check it out. With that, I say thank you.